Second presentation is about Enterprise Architect, the best start for asset management, BIM, and valuable digital twins. This morning I talked about what is enterprise architecture, what is enterprise architecture function, how can you model, why, what are the benefits. And now I go a little bit further also to look at the BIM and valuable twins. This we already seen, and before I go to it, I first want to say something about digital twins. And we made a definition, and that definition is: digital twins are dynamic virtual representations of physical assets, processes, or systems. Digital twins allow us to better understand and better interact with the increasingly complex and fast-paced data-driven world we live in. They allow the vast amount of data that is being generated to be managed, contextualized, and converted into predictions that can inform and guide our decision-making. And with that, we have visualized that in what we called a kind of an infinity loop, where you can capture data in the physical world, that you can describe that in your digital twin. You can use that for predict, and so create a new future physical world by also adding imaginary objects to it. If ready, you can prescribe it. You can also decide on things. And if you have decided, you can change your physical world again. So it's about understanding the physical world and shaping the physical world. We put this also in a small video, and I want to show that video now. It's some minutes.
Okay, Hans, I think you will need to share with sound. The sound is, yeah.
So it's without sound now.
No, it is, yeah. So let's, you can, I will edit this later in the final video, but if you reshare with the sound enabled, then we can play the video again.
Yeah, then I have to go, because, I've logged in again. That is maybe the point.
Yeah.
Can you help me where I have to do that?
So you stop sharing.
Stop sharing, no problem.
And then you go share, and then you choose a screen, but on the bottom left of the dialog box, you say share sound. You click there.
That is the share sound. Okay, I have it. Yeah, no problem.
Okay. So if you go to the beginning.
This is the story of a digital twin, integrating twins building blocks by Royal Haskoning DHV. Digital twins are dynamic virtual representations of physical assets, processes, or systems. They can be applied across all sectors, from water treatment plants to vessels, from manufacturing facilities to financial services. Digital twins allow us to better understand and better interact with the increasingly complex and fast-paced data-driven world we live in. This digital twin starts with notifying its user of a problem. In this case, the Twin Analytics platform generates an alarm that there is going to be a failure in the near future for preventative maintenance purposes. To help understand the alarms, this digital twin visualizes them to provide context. The solution allows you to see the status of an asset to better understand the alarms and early warnings. This is also visible in a 3D view to understand what assets are doing without having to search and select assets. Furthermore, you can easily find static asset meta information, such as size and maximum capacity, to understand possible causes of the problem and how it could be resolved. This digital twin also helps you to predict the future, to enhance your decision-making around how to respond. Upon an alarm or early warning, a twin witness simulation model can be executed using the current system status data to initialize the model, enabling a simulation forward from the current point in time. This enables analysis of the implications of different what-if response scenarios. Scenarios are of course configurable, but in this case, they represent different maintenance response times and disruptions that can last days or weeks, which can have a direct impact on the rest of the facility and processes. These simulation scenarios help you to understand the impact of your decision and identify the optimum course of action. Twin provides digital solutions for decision intelligence that help you connect and understand the dynamics across your organization's physical and digital worlds. Request a demo today.
So, yeah, you saw a video of our company. We made already a lot of digital twins. And they are relevant and across most of, if not all, markets, and they come also in many shapes and sizes. There's not one size fits all solution, and three things are important in it, I think. That is, yeah, you can look at digital twins on a certain level, a very low level, from assets to a system level where processes are in and business services are being generated. And it's also a matter of maturity where you can use the digital twins for. Is it only for the descriptive, or is it also for diagnostic, predictive, prescriptive, or even transformative? And they call that the Gartner staircase, of a value staircase. And another part of it, yeah, you can use digital twin use cases in across all the asset or business life cycle. So the left side is the OPEX world and the right side is the CAPEX world, and you can do it in the operating, in the optimizing and monitoring control, but also in the imagineering, optioneering, and engineering part. And yeah, to be honest, most of my colleagues are working in the engineering part, so that's on the right side, where you can use yeah, digital twin capabilities in your use cases. But yeah, what do you need for valuable and maybe sustainable digital twins? And what you see more and more is that if you bring a lot of data together, the data must understand each other. And that's why there is also a lot of interest now in ontologies or semantics on assets, on systems, and all kinds of relationships between them in networks or hierarchies. And the modern way to do that is to work with semantic triples on RDF frameworks. And if you have done that, then yeah, first you want to understand the why and the what of the enterprise to describe the outcomes and the modeling of the systems and the assets, and that all starts in Enterprise Architect. I showed that this morning, and that you can also make a connection to the relation with vision, stakeholders, all kinds of use cases and requirements. It's the perfect environment to start with your design. And how you relate different elements in your enterprise architecture is also a kind of an ontology. The Archimate technique where you can define processes and application services, for instance, and the relationship over use is also a kind of an ontology to use that. What you see often more in the engineering world is system engineering. And if the enterprise architecture is about the enterprise, system engineering is most of the time about the system of or you must look at a system of systems approach. Then you can also say all the system of systems is also the enterprise And you can also combine those two techniques with each other. And on that, you can plus building information modeling, which is based on BIM standards, on the ISO 19650, and the ontologies who are relevant there. And it's important that the BIMs should be fully synchronized with an AEM master in an integrated ecosystem. Otherwise, there is no consistency between the things which will be built and are built for the operational phase. So next to 2A is 2B is the asset information model, what should be based on asset management standards in the ISO 55000 and ontologies, and you can use all kinds of standards, OTLs and unique classes for standards for naming. And again, dus the EAM is the master in an integrated ecosystem. And yeah, the digital twins then are more the icing on the cake, where you can bring, besides the information of the asset information models and the business information models, building information models, you can add all the data to it from mesh systems, SCADA systems, all kinds of IoT stuff. And you can make the digital twin models. Also important that you use then the interoperability standards, and the digital twin definition language is an important one. And then you can come and build up different type of twins in the operational and asset and the risk simulation, etc. Environment. So what do you need for valuable twins? Yeah, it's a lot. It is architecture, system engineering, knowing business information modeling, asset information modeling, and the digital twin itself. I showed it picture already. Yeah, you can start with capabilities, and if you make a digital twin and you look to BIM and as information model, you can also look to a capability. For instance, a capacity management or service planning. You don't have to do it all, and you can start with that. We call it capability-based twinning, and then build it up in an environment if you need more data for other use cases. Yeah, what you see here is the enterprise architecture modeling. You can also go to system engineering. You can see there's also a little bit as a drill down, more detailed work out of things you already have defined in your enterprise architecture when that's needed. And they're close together, enterprise architecture and system engineering. And I made this overview of the similarities and differences. They're both based on standards. The system engineering technique is a little bit more the V model and the traditional waterfall. You saw also in the presentation of Neil, it came along. As if you go to enterprise architecture, it's more the talk-off and agile safe method, what you have there. System engineering, a lot about validation and verification, and enterprise architecture is more about coherency and consistency of all the models. Techniques, SML and Archimede, I already mentioned them. They're both major techniques in describing languages. The scope is system of a system, and the scope of enterprise architecture is the whole enterprise, is the holistic approach, and the parts what you describe is requirements are very important in system engineering, but also in enterprise engineering. But you have also a lot of the motivation paragraphs, so the why, the stakeholders, drivers, assessments, and goals, etc. Come along. And they have the functional blocks and physical blocks in system engineering and in enterprise engineering. I show you the columns. It's about business, application, and data, and IT and assets. So they're both requirements driven. AI starts with products and services. AI has some limitations on asset modeling. And software engineering is applicable for all kinds of assets, I think. Now, a lot of tooling is there, Relatics, doors, and in enterprise also. Now both is a lot of major tooling available. Enterprise architecture is still often only PowerPoint, but I'm a big fan of the formal modeling with tooling and using Archimate models. If you then look back and look to our semantic layer, then the importance of ontologies, then you see quite a big spectrum from just word lists to a local domain theory. And what you see at the moment is that to describe it well, you have to start really high with hierarchies and networks of those asset processes and systems, and you should use the RDFS and OVL kind of frameworks behind setting up the ontologies with the graph systems, which are there if you put real entities on it. An example with this is a very simple example where you see a semantic description of a building with 3 stories. One story is containing 2 spaces, the other containing more. And it's around a stairwell, and so you can describe the semantics, what you going to use for your models, if it's our BIM, asset information models, or digital twin models. This is a picture you often see where there's a relation between asset management and business information modeling, with the more project-based parts on project information management, delivering all kinds of data to an asset management system. And for operations, you can then use, that's the operate AEM, you can use on that, based on that asset information management. And if you look to the digital twin, you can almost say it's a top off on that asset management system. And that brings me to the end of my presentation, where I try to put all the things I said in one drawing. It's about enterprise architecture, all kinds of model systems and the requirements. You have enterprise architecture. You can do drill downs with system engineering. Then you have the information management part with requirements management. This is the requirements management parts for the 19650, with organization information requirements, asset information requirements, project information requirements. And that is all coming together in the exchange information requirements, where partners in the ecosystem talk with each other, built on ontologies, ontology type libraries, data dictionaries. Then you can make asset information models, building information models, and on top digital twin models. And you have to work with, you have to deliver your release services from an integrated ecosystem. And we call that here a very brave and common data environment 2.0. And that is with asset information management systems, digital twin platform systems, BIM cloud platforms and geographical information systems. Yeah, it's doing this, then you are building up, we think, with valuable and sustainable digital twins. The takeaways: use enterprise architecture for a high-level view on product, services, applications, systems, interfaces, assets, etc. Use system engineering for a drill down on systems if necessary. Define information management with aligned asset information models and building information models as part of those enterprise architecture models. Define digital twins on top of these systems and interfaces defined in the enterprise architectures, which are compliant with the ontologies, because all kinds of data come together and you have to understand each other. And if you have that, then you can run your value-added services on that, like machine learning, like analytics, like control and monitoring in an operational twin, like simulation in an operational twin or simulation in the design phase, or alarm management, etc., etc. Important, if using enterprise architecture techniques and system integration, be sure that you start with one understood Michi meta model, otherwise it will not work. Thank you.